Okay then, so hands up. Just before I start, who in the room is sort of a developer or of that ilk? Anyone? Any DevOps-y type people in here as well? And then architects and security guys? Okay, so there's a bit of a mix, and hopefully there'll be enough in this talk for everyone. So the talk's entitled Security Rationale for Istio. My name's Rowan Baker. I'm nominally the head of security and control plane. It's a grand sounding title, but we're really a 5-man team, so I'm just the security guy. I come from a security assurance and architecture background, so I come at this from a little bit of a different perspective to Andy and Matt, respectively. So in the talk, it's split into 2 parts, as I said earlier. One is just showing how Istio assists in securing Kubernetes multi-tenancy at runtime, and the other half delves into the security of Istio itself. So, just as a context slide, when securing a containerized deployment in the cloud, I just like to think of multiple layers. So obviously at this point in time, most of you are on Kubernetes, so you should know how to securely administer your cloud infrastructure and your PaaS services. And most of you are presumably rolling your own Kubernetes platforms and then looking at managed services. So you'll know that you've got to secure that as well. And if you think you've done some security but you don't know where you lie on the scale with that, I recommend that you use the Center for Internet Security benchmarks. And the benchmarks exist for various cloud vendors, Kubernetes, and various operating systems that you run as hosts with infrastructure. The second layer, or element to think of, is CI/CD pipeline security. Quite simply put, you don't want someone within your organization deploying malicious or vulnerable code onto your cluster. So you integrate various security controls in your CI/CD pipeline in order to do that. And finally, you need to secure the application at runtime in order to prevent a compromise or to constrain the effect that any compromised microservice or pod might have. And this is where Istio fits in. So who here has done some kind of threat modeling activity for their Kubernetes cluster? A few people, okay. Who here has just asked the simple question, what can go wrong and what could a compromised microservice do within my cluster?
Everything and everything.
Yeah, to a certain extent. So, can my compromised microservice eavesdrop on cluster traffic? Which is, to be honest, it's easier said than done, but we must assume it could happen. Could it impersonate another microservice in order to gain access or to escalate privilege within its own application microservice flow? Could that microservice pivot and access other tenants of my cluster? So the network philosophy that Kubernetes is built on is that all pods by default can access each other. So that's definitely a possibility. And then can my compromised microservice initiate some form of outbound connection? And that facilitates various vectors like exfiltrating data or environment variables out of your environment. So you can see quite quickly that at the microservice level, you have you have 3 microservice to microservice specific security requirements. The first 2 are authentication and authorization. The third is encryption in transit. And as security guys, we like defense in depth. So actually we do want some form of layer 3, layer 4 firewalling capability. And luckily for us, Kubernetes has given us that with network policy introduced in version 1.7. Hopefully nobody's running anything that old. Good. So now, when you look at it from the perspective of an organization, you're going to mandate every application team that wants to sit on your Kubernetes cluster to implement security requirements at the microservice level. And you've got all these different application teams working in all their sort of favorite little languages You've got the security versus speed dichotomy that's inherent in all software engineering. And as a sort of throwaway line, it's gotten worse with Agile. And you may also have to migrate legacy applications onto Kubernetes cluster. And those are applications that have no development resource actually attached to them. So you could satisfy this requirement in a couple of ways. Option one is to write your own in-house libraries or use third-party libraries. And then you need your application teams to integrate those into all of the microservices that they write. And then once you've deployed them into your cluster, you need to keep track of all of them, and then need to patch them and keep them up to date. So it's a heavy implementation burden, very difficult to maintain and keep up to date. And actually, if you're starting to write your own in-house libraries for certain things like encryption, you're venturing into dangerous territory. The other architecture option is to use the sidecars. That's a container within the pod that your application container is located in. That gives you a repeatable architecture that then you can roll out for your pods across the organization. The implementation and maintenance effort you can then abstract away from individual development teams. But with each security controlling feature you want to implement, you can end up maintaining a large number of sidecars over time. So the Istio model is obviously to try and bundle all of that functionality into one sidecar. It's the Envoy proxy configured by the Istio control plane. Andy showed one diagram that comes up in every Istio talk. This is the other one. Luckily, Andy's just taken you through the architecture of Istio, so I'm not going to have to explain that to you again, and I won't. But obviously, services communicate exclusively through these Envoy proxies, and that gives us a uniform point at which to enforce security. So if we go back to our Noddy threat model and compare it against the list of security controls that Istio, or security capability that Istio gives us, we've now got mutual TLS between our pods and microservices, gives us encryption and certificate-based authentication. We've got authorization at layer 7 with restrictions on HTTP path and method. We also get rate limiting, whitelisting denials, and egress control. Should also mention that Envoy proxy co-located within each microservice pod gives us a central point from which to collect all kinds of logging and metrics. We'd be remiss if we didn't point that out. So compromised services basically have a blast radius defined by their Istio policy. There is a caveat to that, which is what happens if a compromised service manages to sneak out of the mesh. I'll come on to that a little bit later. And also, there's obviously a balance that you guys need to draw between the amount of effort to configure all of these different bits of security and the net security benefit that it gives you. So threats not mitigated by Istio that you still need to think about yourself. The Envoy proxy doesn't have any WAF capability, so it's not going to protect you from injection attacks. Secondly, if you already have a compromised container or microservice, Istio doesn't prevent that container from attempting to compromise the underlying node, and so forth. So, on to the second half of the talk, which is Istio threats and issues. We haven't developed a formal threat model yet, so this is just really a list of things we've kind of come across so far. And nearly every customer or potential customer we have has asked us, should we use Istio in production? And the truth is that's kind of context dependent, and hopefully both sides of this presentation you can kind of use to draw your own conclusions. Also, if you've got Istio running at the moment, hopefully this half of the presentation flags up a couple of things you might want to think about. The first recommendation or threat is, well, the first recommendation is just really simple. Just like the Kubernetes control plane, keep the Istio control plane secure. When you're installing Istio, enable mutual TLS for the control plane and the control plane to sidecar comms. look out for a couple of flags to enable that. They're the control plane security enablement flag and the control plane auth policy flag. Go look them up and set them to enforce mutual TLS. Secondly, protect Citadel at all costs. So Citadel is the Istio control plane component that's responsible for managing certificates and keys that are used for mutual TLS throughout the mesh. So if you're able to compromise Citadel, you could potentially lead to the exposure of those keys. Istio docs strongly recommend running Citadel in its own Kubernetes namespace and then protecting that namespace with Kubernetes. So you limit access to that to just cluster administrators, basically. Finally, authorization policies, which you can configure using Istio. They're designed for your pods and for your microservices within which your applications run. They're not designed to be used on control plane components. And if you do that, strange, unwarranted behavior will happen. The next threat is user misconfiguration. So Istio only adds to the pile of YAML that you already manage to maintain your Kubernetes cluster. So for each of these pieces of security functionality, you can see multiple different files need to be written. And sometimes for your individual microservices, you're going to need to write those files multiple times. So it goes without saying, avoid any kind of manual configuration. Don't use Istio control. Don't just throw some random YAML that you've cooked up against the Kubernetes API server in an ad hoc manner, because at some point down the line, it will bite you in the bum. Store all of your configuration YAML in Git, subject it to an appropriate process where it's both reviewed and then tested in various environments as you escalate up into production. And then once you've applied it to an environment, regularly reapply it in order to stamp out any manual misconfiguration. So you can use a timed CI server job to do that. We like the GitOps model. GitOps just basically consists of a workload running within the cluster that reaches out to the Git hosting service where you stored all your config YAML, pulls it in, and applies it to the Kubernetes API. And it does that repeatedly. You can configure how often it does that. It does it on the order of minutes. Regularly reapplying Git config doesn't solve all your problems to do with manual misconfiguration, but it goes a long way to doing so. So earlier, I stated that a compromised container is constrained by Istio policy, with the heavy caveat that it remains within the mesh. But actually, what happens if our compromised container manages to circumvent the Envoy proxy and thus leaves the mesh? What can happen? Well, we must assume it can happen. And, well, what can it do? So access to in-mesh services are still going to be subject to Istio RBAC and authentication because they're enforced on the server side. You could use that compromised microservice to attack other non-Istio hosted services within your cluster. So keep that in mind. And also, because your compromised service is no longer part of the mesh, it could circumvent any egress controls applied by Istio. So if there are various layers at which you can apply egress control to your cluster, Istio is one of them. If you're only reliant on Istio configuration for egress management, beware that a compromised microservice can leave the mesh and thus can egress out of the cluster. You can mitigate those two with a Kubernetes network policy, but on the subject of egress, the following is recommended, which is you take a layered approach consisting of a dedicated Istio Egress Gateway, supplement it with Kubernetes network policy, and you can even further supplement it with some infrastructure firewall rules. And so just to explain this diagram, Istio provides a few ways in which you can configure egress. But the recommended way is to use a dedicated Istio Egress Gateway, shown on the right-hand side there. That basically consists of a dedicated Istio proxy through which all outbound traffic from the service mesh traverses. The gateway then acts as a single point at which you can enforce all of your egress policy. To supplement that, use Kubernetes network policies and basically forbid all egress traffic that doesn't lead via the egress gateway. It's very simple. And then if you want to add another layer to that, you can place the egress gateway on a dedicated node using Kubernetes taints and tolerations. And then you can configure infrastructure firewall rules, such as the only egress permitted from your cluster is via that node. So on to another threat, and then continuing with the theme of containers running off the mesh, I just wanted to point out that if you're running init containers being containers you run to configure services and other backends prior to your main application container starting, well, these init containers run prior to Istio initializing within your pod, and thus those init containers run off the mesh. So beware of any malicious code. If any malicious code gets in and runs within that app init container, it's not constrained by security that Istio gives you. Also beware of any of your users or administrators execing into that initialization container when it's running, because again, what they're doing is within something that's unconstrained by Istio. Again, the mitigations are broadly along the lines of what I've mentioned over the previous slides. Use Kubernetes network policy. Andy described pod security policies earlier, and the next piece is it's an issue that leads to a threat. And it takes a little bit of explaining, so bear with me. And this is to do with the lack of compatibility between a restrictive pod security policy and the Istio init and sidecar containers. So pod security policies are a wonderful thing. They're a validating admission controller that a cluster administrator or a security busybody like me can apply. And basically what they do is they prevent any containers being deployed onto the cluster that have any insecure security settings or security context, to be precise. So in this example, on the right-hand side, I've got my pod security policy. For reasons mentioned earlier, I've asked all my pods to run with the privilege flag set to false and requiring it to drop all Linux capabilities. And this is the happy path because my deployment that's going onto the cluster matches those criteria. Now, unfortunately, when you inject the Istio sidecars, notably which consist of the init container and the envoy proxy that eventually runs, the init container requires both the privileged flag and the net admin capability, which it uses to set up the pod's networking. Also, the Istio sidecar in certain modes of Istio requires the net admin capability. So that's in direct contravention to my centrally applied restrictive pod security policy. I basically cannot run Istio without relaxing that policy, and that's a major flaw. So it's a flaw that may be fixed in future releases of Istio by the CNI plugin. It's coming soon. Also, there are some Kubernetes subpod isolation proposals, which I'm not going to go into now, which could fix this over a longer period of time. So just to circle that round to explicitly declare the threat, now I'm running a relaxed pod security policy within my cluster. Somebody or someone could misconfigure an app container at deployment time to run with the privileged flag or to run with the net admin capability. And obviously what that means is if that container were to be compromised, breaking out onto the host would be trivial, or exiting the mesh would also be trivial. The workarounds to prevent this are kind of really quite weak at the moment. You could template out your deployment YAML to explicitly define the security context fields. You could add more latency into the process by having additional reviews and so forth as part of your process. You could use KubeSec as part of that review process, as Andy discussed earlier. And finally, you could use IDS as a detective control. None of these mitigations are as good as pod security policies working properly, to be frank. Just to finish off with, some of the security features within Istio are in alpha. This is from the Istio website, it's from the feature status page. Most notably, at the bottom you can see the authorization RBAC piece is still in alpha. Well, that has some implications for an organisation looking to adopt this en masse, because there's no guarantees on backward capability of the API, there's no deprecation policies, and so on. And I know that authorization is something that's improving rapidly with the coming releases. For example, the 1.1 release has an authorization permissive mode in there as an experimental feature. That allows you to test your authorization policies in production without actually blocking traffic, just to make sure it works before you roll it out. So other pending improvements to Istio coming in version 1.1. 1.1 is imminent. I think it's scheduled for roughly the end of February, but I can't really, don't quote me on that. There's TLS health checking, it's coming in 1.1. There's that much needed CNI plugin that I mentioned earlier. And there's a whole bunch of other improvements on the way as well. Most notably, pluggable CA adapters. So if you're using Vault within your current infrastructure to provision certificates and things like that, there's an Istio integration with Vault on the way as well. So this sounds a little bit pitchy, but in conclusion, for large organisations looking to run large multi-tenancy Kubernetes clusters, Istio is still like quite an exciting project, because it solves at scale for minimal code changes made by your developers. It solves a whole bunch of security problems by giving us authentication and authorization, encryption and transit between pods. Now, as you've seen in the last sort of 5-10 minutes, it's still a maturing project. Some improvements are still required, and some features are still in alpha, but it's definitely something to keep an eye out on and consider in the future. And that's it. Thank you very much.